take any questions because we already time bad. I really want to now welcome the representative of RENU. Brian, please unmute yourself and speak to the gathered schools here. Can we spotlight RENU?
Hello. Hello, Mr. Dungu. Can you hear me well?
Yes, we can hear you well, Brian. Go ahead.
Okay. Thank you so much, Mr. Dungu, for giving us this opportunity to speak.
And you can tell us even your former school, what it was.
Thank you so much. I am Brian Masiga from RENU. I'm a senior network engineer here at RENU, and I'm representing the RENU CEO today in the seminar. I also associate that I am a former old boy of Busoga College Mwiri from 2003 onwards up to where I completed my studies. I would like to say that I also went through the hands of Mr. Dungu as my mathematics teacher, and I'm very impressed of what is happening here today. I have been listening through the seminar, and I'm very impressed with what the students of the different schools have done, from Iganga SS to Navisunsa to St. Mary's College, Chisubi. Please, Gayaza High School, guys, that was very amazing. And during this pandemic time, Mr. Dungu and the Help Initiative have been very good at doing this, and having this seminar has taken us a very long way to appreciate the internet and the technologies. So a vote of thanks to Mr. Dungu and his team, a vote of thanks to Mr. Arthur, my headmaster from Busoga College Mwiri, and a vote of thanks to all the schools, all the teachers, and everyone that has participated in making this very good. I want to say congratulations and thank you so much. I would like to speak a bit about who RENU is. RENU is the Research and Education Network for Uganda. We only serve institutions in education and research where the schools now fall. So with the schools part of the RENU network, we are very grateful and ready to serve you, to provide the internet and also give you other services on top of the internet. So the internet is just a road to reach the market. What we are doing here today, initiative is doing, is what makes the market very important. So I want to say that RENU is here to serve you. We are here to build the network. We're here to provide internet, and on top of that, provide other services like Zoom. So in case you're not yet connected to RENU as a school, please reach out to us. Only serve research and education institutions. And all this couldn't be possible without the hand, the invisible hand of the Uganda Communications Commission. So what UCC has done for the schools is very amazing. So we would like to also extend a thanks to UCC for what they're doing. For us, RENU, as the future is with you, the students, the teachers of the schools. So reach out to us wherever you want us to help you serve for some of the things that we are doing in mathematics and any other course, any other studies that we would like to do. I saw what St. Mary's College Chisubi did online. That was very amazing. We have the tools that can help us do these seminars. So thank you so much, Mr. Dungu. Thank you so much, the Health Initiative. Thank you so much, UCC, and all the schools. Enjoy the seminar. I will still listen in and learn a lot from you. The mathematics that has been demonstrated here has been very good. Thank you so much and have a good day.
Thank you, RENU, and thank you, Brian, for coming to our rescue as schools and connecting us. This is helping us to close the gap between the urban and the rural setting, and this is very interesting. We expected to have a representative from UCC, but unfortunately we have not. If they come on later, we shall be able to give them time to speak to us. Otherwise, we are very grateful for all the support that you are giving us, and we hope to continue getting more schools online by your connection to the schools. We will now continue with the presentations. Makerere College, are you ready? Makerere College, can you turn on your video? Turn on your video so that we can spotlight you. Henry, do we see where Makerere College, where are you? Could you tell us who you are? Are you
using Jonathan?
Could you also make sure in the next session you write that as Makerere College for our record? Okay, over to Makerere College.
This is Makerere College School. My name is Joshua. I'll be doing number 9A, part 1. Then my other friends will come and do the other parts. So in part 1, we've been asked to find the volume of water which can fill the vase. But as you know, a vase, the part of a vase is, it really comes from a cone. At first, it's something like, it's a cone. Then like it was just cut here. Now I've been told to find the water that can fill the vase. So just telling us to find the volume of this vase, which will be equal to the volume of the water. Now in order for us to find the volume of the vase, we have to find the volume of the cone, the whole cone. Then we're going to subtract this whole, we're going to subtract this other small cone down here from this whole cone to get this remaining part, which will be the volume of water which can fill the vase. Now we have been given that from here to here, that's 100. Then I've been given this diameter, which is 40. Then I've been given this diameter, which is 80. Now, since we don't know this one, let us say that this is x. Now, here we're going to have to use the method of similarities, where it's going to be big diameter out of small diameter, which is equal to the big height out of the small height. So in order for us to find this x, so it will be big diameter out of small diameter, which is equal to the big height out of the small height. Now the big diameter here is 80 out of the small diameter, which is 40. It's going to be equal to the big height. Here we're going to have to add 100 plus this x to get 100 plus x. Then plus this other small height, which is going to be x. Now here we're going to have to cross multiply, which is going to be 80x is equals to 440. We shall have to put this in brackets. Now here is 80x is equals to, this is going to give us 4,000 plus 40x. So when you bring this 40x this side, it's going to subtract this 80x, which is going to give us 40x is equals to 4,000. Now here, when we divide here, in order for us to get the x, we're going to find it with that x is equals to 100. That means we have now found this other one. So this x is equals to 100. So we now have also the height of the cone. Now that we have the height of the cone, we are going to now have, now that we have the height of the cone, we are able now to find the volume of the whole cone. Then we're going to have to subtract it from the volume of this. Whereby volume is a third pi squared height. Now that means we're going to say volume of the big cone minus volume of the small cone. Now volume of the big cone is going to be a third times pi squared is 22 over 7 times our radius. Our radius here, our diameter is 8, so we're going to have to divide it by 2. That will give us 40. That will be 40 squared times our height is 100 plus this 100 is going to give us 200. Then we're going to subtract it by the volume of the small cone. It's going to be a third times 22 out of 7 times, here it's 40, this is the diameter, so we're going to divide by 2, giving us 20, is the square inch times. Here it's the small height is going to be 100. So when you get this, so we'd have to work out this and subtract this from here. So the volume of the beacon is 335,238.0952 minus minus 4190.4.7619, which is going to give us
no, we should be able to get it. No, we can see it.
will give us 293.3333. Now this is the volume of this other side that had remained, which is in cubic centimeters. That's our answer. Thank you.
Next one.
Right, I'm Makerere Abraham, and I'll be taking you through number 9, A Roman 2 of the question on the page. Now, number 9 Roman 2 asks the volume of the material which is used to make the base. Now, I want you to perceive if that is our base. Now, I want you to understand that the material, the volume of the material that is being used to make the material of this, the material that was used to make this vase is what I can call the thickness of the vase. Now, the thickness of the vase is, in other words, this part. Now, they want us to find the volume that just that bit occupies in the whole first one. So this is what we are looking for. Now, in order to get the volume that this has occupied, we shall find ourselves getting the volume of the cylinder minus the volume of water. Now, the volume of the cylinder is found by multiplying the area of the bottom circle. There is a circle that is down here. Now, if we are to find the volume of this cylinder, we shall find the area of this circle, and we shall multiply it by the height of this cylinder. That is how we are finding the volume of the cylinder. Then we are going to subtract the volume of water. I mean, yes, the volume of water which is occupied by the volume of this frustrum. Because once we are to put water into this cut cone here, if we are to fill it with water, the volume of this water will be equal to the volume of the frustrum itself, which we found in A, the volume of water which we found in A Roman 1. Now, the volume of water, which we can just put it there as 29333.3333. I would advise you to keep it, to use the 4 decimal places. This is because it will help you, it will prevent you from getting a premature answer. Now, we are finding the volume of this cylinder. Now, the volume of this cylinder, like I told you, is area times the height. Or you can just use pi r squared height, which is the pi r squared height. Now, the pi r squared height is we are trying to find the area of this circle. Now, pi is 22 out of 7. If I'm not given you whether to use it as a decimal form, which is 3.14, I advise you to use the fraction, which is 22 out of 7, times the radius. The radius of this is given now that is how our cylinder will look like. And in the question, this is how it exactly looks like. We are told that this is now the radius which are half of this and half of that. Times the height of the cylinder. Put this directly into your calculator, and you find yourself yes, we shall be getting 63,640. We shall be getting 63, 64, 28.5714. Here we shall have 63, 64, 28.5714 minus the volume of water, which is 29333.3333. And the difference there will be, once you subtract this, you get 9.263.71429 centimeters. Sorry, apologize. We shall be getting 3,43095.2381 centimeters cubed. Thank you.
Another part?
My name is Senton Joshua Benjamin, Makerere College School, and I'm going to do part B of the question, and it is asking us to find the total surface area of our vessel. Basically, it is, as you can see here, it is a cylinder. So I'm going to find its total surface area. Now, you must know that a cylinder as a whole, it is not so very simple to find its area, so we have to expound it. And let me show you how we do it. Now, this is what I'm doing. At the bottom here, we must know that this bottom part is closed. And then the upper part is open. Now, in order to find its area, we have to elaborate how it looks like. And if I'm to stretch it out wide, I'll get a what? A rectangle. And then this downer area, if I remove this, if I expand it, this downer part is covered by a circle. So this is the circle that I get. And then the upper part for it is open. So for it, we leave it. But you must take note that it also has some kind of smaller circle. Why? Because there's this thickness, and that thickness is the material in which we made our what? Our vessel. And it should also be included in our surface area when we are finding our surface area. This is pi r squared, the area of this circle. Then, as you all know, this is the height, and then now. This is circumference of our circle. Why? Because when I got my cylinder and I elaborated it out, this part was covering the circle. So when I remove it, that is the circumference. When I expand it, that is the circumference of the what? Of the circle. Then this is the height it was given to us in the question. Let me proceed. So, now, the reason as to why I'm saying length times width is because this is a rectangle, and if you are to follow standard procedure, it is length times width. But our length is h, and our width is circumference. So let me also substitute for that. We are adding this area plus this area because you are trying to find the total surface area of our vessel. Plus length, which is h, then times the circumference. The circumference is basically pi h. Now, the d is the diameter, and diameter is the same as 2r. So I'm going to remove this diameter and I replace it with r, 2r rather. By r h. Now, if I'm to look closely, I see a common factor. I hope you also see it. The common factor is pi r. So I remove it, then I remain with r plus 2h. Now that is the area of our cylinder. But remember, I told you there's a small circle and a bigger one. So you also have to find its what? Surface area. So I'll add. Now I'll first get the area of this first big circle. Its radius is what? They gave us the diameter, but the diameter is 90. So if I'm to get the radius, I divide it by 2. Then so it's with a big one, then pi r squared is like a small one. 22 out of 7. As my colleague said, always take note that if they don't give you the pi, in points, you have to use this, the fraction form, okay? Then times the radius. Now we are going to use the radius of this because we are still analyzing the series, which is 25 into same same radius, then 2 times the height, which is 100, plus. Now we are now back to the other small and big circle, okay? This is 22 out of 7 times 45. This is for the big one. This B is for big circle. Then minus. Now the radius of the small circle, which is the inside part, they give us diameter as 80. So the radius is 40 squared. Yes. We are fine to the surface area. Someone please complete for me. We are here.
Let's complete very fast. Complete the last one.
Please give him a chance to do his question, otherwise you'll get lost.
Now, this is the area of our cylinder, and then this is the area of our big circle, then minus the area of the small one. These are some of it. Sorry, this is after we've already subtracted this. So then you just add it, and you get.
I'm ready. Because here they're asking, may you please elaborate more on how you got 45?
Now, you first write it to 4 dps, then you write your final answer and you round off to the first decimal place.
The pen. The paper.
If you don't do this first, then this number you get here will be a premature what? A premature answer. So you have to first write that 4 dp, then you go to this. And that's how we'll find it. Thank you very much. Stay blessed. Okay. I've received a question that how did I get 45 as the radius?
Okay, can we, maybe we can keep the questions for now. Do we have another question, the third question?
Yes.
Could we have it, please? We are running short of time, but take note of the question.
Good morning, everyone. I'm Cesar of Makerere. I'll be taking you through part C of the question. Well, it says, if a tap is open to fill the vase at 50 centimeters cubed per minute, how long will it take for them? How long will it take to fill the vase? In our part 1, the first part of the question, we're able to formulate the volume that is attained in the vase. First thing, we're going to extract off the data that is being given. The data is being given 50 centimeters cubed. This is for the tap. So this, first interpret it. It means 50 centimeters cubed will take 1 minute. So write 50 centimeters cubed. What about 1 centimeter cubed? That one takes I mean, but the volume of the base that you got was 29333.3. That one will take so our answer will be we maintain the 4 decimal places with accurate answer. Thank you.
Okay, thank you, Makerere College, for the presentation. I know we missed you in the practice sessions and the preparation sessions, but we are happy that you've come alive this morning. Smack, are you there?